Alright, so for problem 13, you asked about finding the y value. So we're gonna first do the derivative to get, the first derivative, and then we do the second derivative to get concavity. So the first derivative is the slope, and I'm gonna use power rule. So this 4 comes to the front. 4 times 1/4 is just 1. So you get x. You subtract 1 from 4 and you get 3. Minus power rule again. 2 goes to the front, multiplies with the other 2, and so you get 4x. So that's the first derivative. Then from there we're going to do the second derivative, because the second derivative tells you concavity of a function. So that's 3x squared minus 4. So that's the second derivative, and I'll write it here. This tells you concavity. Again, concave up, concave down. This is concave up. This is concave down. And this first derivative tells you the slope of a graph. If the slope is positive, the function is increasing. If the slope is negative, the function is decreasing. Alright, so for the second derivative, we're going to set it equal to 0, so we could find the points of inflection. So 3x squared minus 4 equals 0. You add 4 to both sides. We're basically solving for x at this point. 3x squared equals 4. Divide both sides by 3. And you get x squared equals 4/3. And then we're going to square root both sides to solve for x. And you get x equals plus or minus the square root of 4/3, which turns into plus or minus the square root of 4 over the square root of 3, which equals plus or minus 2 square root of 3. So that means there's two possible answers for x. X could be either positive 2 over square root of 3 or negative 2 over square root of 3. And those two values for x could be your points of inflection, but we gotta check. Alright, so we have these two x values. I'm gonna make a sign chart for the second derivative, f double prime, because I wanna find where is it concave up, where is it concave down. So one of my x values is 2 over square root of 3, and my other x value is a negative. So one's going to be negative and the other one's going to be positive square root of 3. So I got to check numbers. I got to check a number, for example, right here. Right here, I got to check a number between negative 2 and 2. So I could check 0. I'm going to check 0. I'm going to check a number to the right of 2 over square root of 3, so I'm going to check 10. So a number over here in this area, let's say 10. And I need to check a number over here in this area, so I could say I'm going to check negative 10. So basically I'm going to check those three numbers, and I'm going to check those numbers on the second derivative. So the second derivative is right here. I'm using this new pen, this new feature, so I'm still getting used to it. Oh, perfect. Oh no, I thought I could copy and paste, but never mind, still good though. So with the second derivative function, I am going to test a number to the left of negative 2/3, test the number to the left of this. So I'm going to check negative 10. So if I substitute negative 10 into the second derivative, then I get negative 10 squared, which is a positive number, positive 100. 3 times a positive 100 is a positive number of huge, so I get a huge positive number, which is 300. 300 minus 4 is a positive number. All I need to know if it's positive or negative, because in this area, in this section, these are all positive numbers, which means this is concave up. I'm going to check 0 now. So using the second derivative, I'm using 0, 3, 0 squared minus 4. So if I use 0 now, I'm trying to get like an answer whether, to find out if it's positive or negative. So 0 times 0 is 0, 0 times 3 is 0, 0 minus 4 is negative 4. So here I get a negative answer. So in this region, these are negative concavity, negative, well, the answer is negative, so that means concave down. And I still got to check a positive number, so I'm going to check 10. So f double prime of 10, 3, 10 squared minus 4, which is 10 times 10 is 100, 100 times 3 is 300, 300 minus 4, 296, positive. So this is a positive number. This is positive, 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 which means concave up. So there is a point of inflection, and your point of inflection is, I'm looking for a highlighter, but I can't find it. Give me a second. Highlighter. Point of inflection is here. And your point of inflection is here because that's where concavity changes. So we're going to write it like this. POI at x equals plus or minus 2 over square root of 3. So those are your point of inflection because concavity changes. So I guess this is what you were asking about the y values. So Eric, to find the y values, you gotta take the x, you gotta take this x answer and plug it into the original equation. Sorry about that. The original equation. So the original equation is f of x. It's this equation here that I'm gonna move. Give me a second. I need to move this. Okay, I'm just gonna write it again. Sorry. So the original equation, which is f of x equals, I have to go back and forth, so give me a second. 1/4 x to the 4th minus 2x squared. 1/4 x to the 4th minus 2x squared. Let me just double check. 1/4 x to the 4th minus 2x squared. Okay, good. So that's the original equation. And I need to substitute the x values, the POIs. So f of 2 over square root of 3 equals. And you're also going to substitute the negative. F of negative 2 over square root of 3. You're going to substitute it into the original equation to get the y value. So 1/4 parentheses 2 over square root of 3 to the 4th power minus 2 over square root of 3 squared. When you do the math, it'll give us the answer. So let's try to do it then. You have 2 to the 4th power, 2 to the 4th power, 2 to the 4th, and you have square root of 3 to the 4th minus 2 squared over the square root of 3 squared. So we have now 2 to the 4th. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Oh, sorry about that. I don't know why that happened. Okay, so here you get 16. 2 times 2 is 4, 4 times 8 is 16. And on the denominator, you have the square root of 3 to the 4th power. So that means you have square root of 3, square root of 3, square root of 3, square root of 3, minus 2. 2 squared is 4. The square root of 3 squared is just 3. And right here, you're really going to have 3 times 3, which is 1/4, 16 over 9. 3 times 3 is 9. Minus 2 times 4 is 8 over 3. And here, I'm almost done. Well, I'm going to simplify like this. 1/4. So I get 4 over 9 minus 8/3. I need a common denominator, so times it by 3. 4 9s take away 8, 16, 24 over 9. And so the answer would be negative 20 over 9. And that's your y value. But you still got to get the other y value. So I'll let you try that, Eric. And you're basically substituting the negative now into the original equation, into x. You're substituting negative 2 over square root of 3 into the original equation to get the y value. Alright, good luck.